Okay, this is James Jopling again with Shoppa's John Deere. These are the hydraulic components of our 2021 Tech Challenge contest. First of all, we've got a hydrostat unit, kind of a little dude, but it's out of a lawnmower, but it functions all the same as even large machine hydrostatic units. Okay, first question is true. The hydrostatic charge pump is an open center hydraulic providence pump. That's that little dude right there. And it is an open center pump. Okay, the next question is false. The hydrostatic drive is a self-propelled unit requiring no external power. That is incorrect. You have got to have some kind of power providence. In this case, it's a lawnmower engine. It's just a small Briggs & Stratton or Kawasaki engine, but you must have an external power source for that. Now, the next question is false. A hydrostatic drive is a fixed displacement pump with a variable speed motor. Now, it's not a fixed displacement pump. The pump, every time this piston goes against and what's called a swash plate, pushes it down, it pumps, and it's contingent upon the angle of that swash plate as to how much it's going to pump. Yeah, it may just move it a tad bit, or it may move it a large amount. And that way it's going to also react over here. That is variable speed motor. Variable displacement pump and a variable speed motor. Next question is true. If the hydrostatic motor swash plate reduces angle for the piston stroke, the speed noted will decrease. That's true because it's not going to be moving, the pistons aren't going to be moving nearly as far. So that question is true. Next question is false. This entire unit displays only minimal damage and thus can be repaired. That is incorrect. If you look at the housing, there's significant gouging and scoring, so that cannot be utilized again. So that is all on the hydrostatic drive unit. Our next component is rather interesting. It's a hydraulic accumulator, which is, if this is a bladder type accumulator, and generally it's going to have dry nitrogen pumped into this side, pressurizing it, and it's variable pressures contingent upon application. And hydraulic oil will be entering into this portion of the chamber. And what's going to happen is the hydraulic oil, first of all, this is going to be pressurized with dry nitrogen. Then the hydraulic oil entering in is going to actually push in here, and with that pressurized cavity in here, it's going to add cushion. And then when you discharge, or say you shift a gear or something, you need a little bit extra oil. This being pressurized is going to force that bladder down, forcing a little extra oil into whatever particular circuit of which you have. All right, so the first question is true. The pressure within the gas-filled bladder is proportional to the dampening of the specific hydraulic system component. That's true. If the pressure is too low, then you're going to have reduced dampening, so to speak. If it's out of your dry nitrogen, this compartment, this is just going to be, this cavity will be filled up with hydraulic oil and you will get no dampening effect whatsoever. Now, the next question is true. An accumulator will reserve pressure, oil, and volume as to where, when a slight pressure diminishment within the system, it will provide compensation of such demands. There again, as we were speaking of earlier, if you've got this is a pressurized cavity, and this is filled with oil, when you have demands elsewhere in the hydraulic circuit, this is actually going, because this is pressurized, it's going to force whatever oil is in here to help supplement that particular hydraulic circuit. Okay, so now the next question is false. An accumulator will allow a fluid or gas pass-through dampening. Now this is just, this has no pass-through whatsoever. Now an attenuator is somewhat, it's a pass-through device, kind of like a hydraulic muffler. But this accumulator, it has no oil that's going to actually pass through. Now the next question is false. If the bladder within the accumulator is ruptured, it will still function properly. There again, if the bladder ruptures, the entire unit's going to be filled with oil and it will have no dampening abilities whatsoever. Now the last one is false, obviously, but there are several different types of accumulators, but this is false. This is a spring type accumulator. No, this is a gas-filled accumulator. But anyway, that covers all the questions on a hydraulic accumulator. Now our next component is one I also like, is electrohydraulic valve. Okay, this valve, it's got a coil inside, and I believe this one was a pulse width modulated EH valve, but that coil, when it's actuated, will actually move a spool, and then it'll give oil, it'll direct it down further, which will move an additional spool in here. But anyway, our first question concerning this type of valve is used to function hydraulic operations. That's true. It's very, very true. Now the next one is false. If the electrical providence is diminished to the coil, there will be no notable directed hydraulic function performance. Well, if that coil should fail within here, then it will not manipulate this spool, which you will not be able to direct any hydraulic oil with that spool. So you will see an issue. Now the next question is true. If directed hydraulic control function is not functioning properly, possible cause may be loss of pilot pressure. Now we do have a breakdown here as to where the pilot pressure actually helps control and direct that spool. So that's true. The next one is true. If the sump port is blocked to the directed function, it may remain engaged even though electrical providence to the coil is discontinued. The sump port, actually, what it is you've got a spring right here that's going to, when you have electrical providence discontinued, it's going to move this up and allow this spring to force this spool back up into a closed position. But it opens what's called a sump passageway to where it can disperse, it can dump, so to speak, the oil that was sent to whatever hydraulic circuit it was providing. So it's got to be able to relieve that pressure. Now the last question is true. If the return spring should fail, the directed hydraulic flow to the control mechanism will remain engaged. Possibly yes. If that should fail, then it'll allow this to continue to be all the way down, keeping port open and the directed oil going to whatever hydraulic control circuit we have. So that is all of which we have on the electrohydraulic valve.